Greetings, learners, and welcome to Get Smart with Stanford. Today, we are going to look into grade 11's paper 1. There's a particular question which is very common in grade 11 paper 1. It contains radical or surd equations. This has been a problem to a lot of learners who have been asking me this question. What is this? How do we deal with this? And it's very simple, and I'm going to show you just how simple that is today. So, what are radical or surd equations? These are such equations that have a square root. They are algebraic equations which have square roots. So, we are required to solve for x on such algebraic equations which have square roots. What are algebraic equations? Algebraic equations are the equations that have letters of alphabets such as X, which is very common. Y can be Z, can have your M, your N, or whatever it may be that can be used. So these alphabets are called variables, and these variables are replacing numerical values which we could have used if we were not using those variables. So these algebraic equations contain um, such variables which we would need to solve. So yeah, if we're told to excuse me about that, to solve for x, how were we going to solve for this particular x in an equation that looks like this? Square root of x minus 1 plus 3 equals x. Let me maybe give you 30 seconds to think about it and see how you would best solve such an equation. Just think about the basics. How would you attempt this kind of a question? All right. Now let us work on this one together. It's not a very big problem. So what we need to do here is try by all means to leave the square root and whatever that is inside the square root or under the square root on one side of the equal sign and everything else on the other side. But if we were to have something which would be multiplying this square root, for example, if we had 2 square root of x minus 1, because that 2 is one term together with the square root of x minus 1. We would not have to transpose that one just anyhow. We would have to think about it and see what we can do with it, because it's not much of a problem being there. It can be worked on so easily. So now let us look at how best we can solve this one. Firstly, the first thing that we need to do is to transpose. Let us transpose the 3 to the other side and leave the x minus 2 under the, beg your pardon, the x minus 1 under the square root, or the square root of x minus 1 on one side. So this would be equal to x, but we know for sure that when we transpose these 3 with its sign going to the other side is going to change, and is going to change the sign from positive to negative. If it was negative, it was going to change from negative to positive, but in this case we're going to have x minus 3. What else can we do in this case? We will remember that in the case that you have the square root of x raised to the power 2, this is the same as the square root of x times the square root of x. We are told that when we want to remove the square root, we need to raise it to the exponent 2. So now I just want to show you exactly why we are doing that. And in exponential form, the square root means to the power half. So we would have x to the power half times x to the power half. And this is the same as x to the power half plus half, because according to the rules of exponents, when we have the same base multiplying each other, we add the exponent. So that's how easy it's going to be. But we know for sure that half plus half equals 1. Hence, we're having x to the power 1, which is just equal to x. So when you and this x is that which is under the square root. So all the time they tell you that when you remove the square root, you raise it, or you raise that equation to the exponent 2. That's because the square root is to the power half, and if it's multiplied by 2, then you get half times 2, which is equal to 1. That's how we deal with the square root. I'm not going to explain this in the next questions. I may not explain this because I've already explained it. So what we're going to do now is to raise this. The next step is to raise this to the exponent 2. But remember, in mathematics, what you do on the left hand side, you also need to do on the right hand side. So we are going to raise the right hand side to the exponent 2. As we have done that example here of the square root, we know that when we square whatever that is under the square root, we are going to remain with what is under the square root, and in this case it's x minus 1. So when we square x minus 3, maybe let me choose a different color. This one is a little bit funny. I don't like funny colors. Let's use a straight blue. um, we are going to have x minus 3 into x minus 3. So I'm just jogging your mind, reminding you of something which you have done in grade 10 and probably in grade 11, in grade 9 also. So yeah, in grade 11, we just jogging your mind. You already know this. So when you multiply this out, you know that you're going to multiply x by the x on the first term on the other side of the brackets, and you do the same with this. And this one, when you multiply this one, you take consideration of the sign. You're going to multiply this, and the same term will multiply the other term. Here we're going to have x squared, that's x times x is x squared, and x times minus 3 is minus 3, and minus 3 times, yeah, it's minus 3x, I'm going to say, and minus 3 times x, it's minus 3x. Minus 3 times minus 3, that is positive 9. I'm not going to do these kind of examples in the next questions because we would already have done them here. Then we know how to deal with this. So here would be left with x squared minus 3 minus 3. This is minus 6x plus 9. So this is what we are going to have. So this on the right hand side, we're going to have x squared minus 6x plus 9. So now let me erase this. Let me erase this and show you just how simple this is. So since we have this, then why wouldn't we transpose this whole thing? Because now there's no longer a burden of a square root, which was giving us a problem in the previous step. So now we have gotten rid of the square root. What do we do next? We transpose this to the other side. We are going to have 0 because we are taking everything else to the other side, and this side on the right, on the left hand side, will be left with a 0. So it's 0 equals x squared doesn't have any like term, so it will remain x squared. Then we group the other like terms. So the x, we have minus 6x, and we know that the x, when it transposes to the other side, is going to change the sign from positive to negative. Then we're going to have minus 7x. That's minus x minus 6x. It's going to be minus 7x. And this one, minus 1, is going to the other side and is going to change its sign to positive. Then we have 9 plus 1, which equals a positive 10. But usually we have it in a standard form of this way: x squared minus 7x plus 10 equals 0. This is the standard form that we know. So let us see if we can factorize this. I'm going to show you this just once again. How to factorize? How do we factorize? We find the factors, two factors of 10, that when we multiply them, we're going to get positive 10. But when we add them, we're going to get minus 7. So what are the factors of 10? The first one that are easy, it's going to be 10 and 1, because 10 times 1 equals 10. But from 10 and 1, can we get 7? Definitely not. We can either get 11 or 9 or minus 9, something like that. Another factor is 5 times 2. 5 times 2 equals 10. And 5 plus 2 equals 7. But we need to put the signs in the sense that we're going to get minus 7. So minus 5 minus 2 equals 7. Minus 5 times minus 2 equals positive 10. Then we've got our factors there. So we're going to apply them here. We will have x minus 2, x minus 5 equals 0. Let me just draw a line here so that we can have the other space to use. I've got a big space here. So when we have it like this, we equate each one to 0. X minus 2 equals 0, or x minus 5 equals 0. When we transpose, we're going to have x equals a positive 2, or x equals a positive 5. This is so nice, beautiful. We now have our two x values. But then, because of the square root, we need to check if these ones, if they are plugged or substituted back into the original equations, they are going to give us a real root or not. So let us try with not actually a real root, and the left hand side must be equal to the right hand side. Okay, let me show you how. And the next one, you'll see just how easy it is. So we will remember that our original equation is the square root of x minus 1 plus 3 equals x. Let us substitute the first x value, which is positive 2. Wherever we find x, we substitute by 2. So we'll have 2 minus 1 plus 3 equals, wherever we find x, we put 2. So what is 2 minus 1? 2 minus 1 is 1. So it means whatever we find here must be equal to whatever is on the right hand side. So the square root of 1 is 1. And 1 plus 3 is 4. 4 equals 2. But no, 4 is not equal to 2. 4 is greater than 2. So we write 4 is not equal to 2. We cross the equal sign just like that to show that the left hand side is not equal to the right hand side. Let us see if the x equals 5 will suit this equation. We'll have the square root of 5 minus 1 plus 3 equals 5. What is 5 minus 1? That is 4. We have the square root of 4 plus 3 equals 5. What is the square root of 2? I'm sorry, I just gave you the answer. The square root of 4 equals 2. So we have 2 plus 1 equals 2 plus 3 equals 5. And then 5 is equal to 5. What does this tell us? It tells us that x equal to 5 only. Why is it equal to 5 only? That is because when we substitute 5 in that equation, we are getting 5 from both sides of the equal sign, which is what we wanted to see. And when we plug or substitute 2, we are getting 4 and 2, which are not equal. So our value of x in this case is 5 only. So let's erase this and check the next one. I hope you are grabbing this into your minds and we can do the next one together. You will be flowing. And feel free to get my number on the videos. I'll try to put it on at the end of this video so that you can WhatsApp me. Just text me if you need any assistance. I will assist you so easy. So yeah, we're still solving for x. This one I shouldn't have erased because we continue to solve for x. And the second one says 3x. Now I just gave 3 square root of x. I just gave an example similar to this one in the previous example, equals x minus 4. So when you have it like this, because this 3 is multiplying the square root of x, that is one term. So there's no need to transpose or do all these other things. Either ways, we wouldn't transpose that because it's one term. We would have to transpose it as a unit. So when we have this, we straightforward raise this to the exponent 2. Why the exponent 2? Because we want to remove the square root so that we can be able to solve for x without any difficulty. This is the easiest method I've ever seen. So if we have that, by the laws of exponents, you can watch one of my videos. I titled it laws of exponents. You'll see that when we have exponents like this one will be distributed to both. Then we'll have 3 squared is 9, and the square root of x squared is just x, equals, here I've shown you how to deal with this one. Then now I'll just continue to say we have x squared and we have minus 8x plus 16. I believe I'm right. Still mathematically correct. And we will transpose this whole unit to the other side and it will change the sign. Then we group it with its own like terms while at the same time writing it in standard form. I've shown you why we're doing this and how we do it. We have x squared minus 8x minus 9x. That is minus 9 plus 8, that's minus 17x plus 16 equals 0. Then now let us see if we can have any factors of 16 that would fit into this equation. But now if we say minus 16 and 1, yes, you will have positive 1 minus 16. If you want to see if these values really are correct or these factors are correct, just multiply everything as I have shown in the previous example. You multiply them like this, and then you must when you multiply this, you must get this. If you don't get that, then the factors are wrong or you have multiplied incorrectly. So here is the thing. Let us put the bracket back. Do not forget to equate to 0. Then our x plus 1 equals 0, or x minus 16 equals 0. The value of x in this case is, we transpose the positive 1 to the other side, is going to be minus 1. And when we transpose negative 16 to the other side, is going to be positive 16. So our x equals minus 1 or x equals 16. But now we need to check if indeed these values are going to suit these equations. So our equation is, let's do this in red, 3 square root of x equals x minus 4. So wherever we find x, let us start by substituting minus 1. So I think we've gone wrong somewhere here. We went wrong here during the factors. I'm now looking at it and I can see that now this doesn't make any mathematical sense, because if you multiply this, you are not going to get 17, but minus 16 minus 1, that's equal to minus 17. So it means the value of 1 is positive, and here we have a negative also. Then we get a value of x as positive. Then now let's go back to substitute here. See, that's one of the mistakes that we are making in mathematics, and we need to be very careful whenever we are writing our test exams or whatever it may be, that we are careful of the signs, and we try and test if everything that we've applied is correct or not. Because had I gone to the end with this, I would have gotten a wrong answer, because we do not have a square root of a negative that will give us a non-real root. So now let us substitute by 1. 3 square root of 1 equals 1 minus 4. So square root of 1 equals 1. 1 times 3 is just 3, equals 1 minus 4 equals minus 3. And this is incorrect. 3 is not equal to minus 3. You need to show that 3 is not equal to minus 3. So why am I even doing this as if this is the final answer? It shouldn't be. Now let us continue and substitute x by 16 and see if it's giving us the correct one. So the square root of 16 is 4. 4 times 3 equals 12. 16 minus 4 equals 12, not 4. 16 minus 4 equals 12. Then our correct value of x equals 16 only. Now I think let us try and look into the next two. And when I look at them, the other one is a little bit tricky. I haven't done them also, but I will do them together with you. Okay. The third one, what does it say? The third one says, oh, x. It's the square root of x plus 28. The square root of x plus 28 equals x minus 2. So if it's like this, also, because on the left hand side we've got one term, which is the square root of x plus 28, we can simply raise to the exponent 2, because we want to remove the square root. So if we have raised this to the exponent 2, here on the left hand side we're going to be left with just x plus 28 equals, I've shown you how to do this one, x squared minus 4x plus 4. I believe that's what you're going to get. Blah, blah, blah. Yes, you're going to get that. And then we transpose and group the like terms. X squared, there's nothing that is got a squared, so it's just going to be on its own. Doesn't have a friend, this one. So x squared without a friend is lonely. Then we transpose the x to the right hand side. It's going to be minus x, then minus 4x minus x. We have minus 5x. And this time I need to do this right. I need to calculate it right on my head. We're going to have 28 transposing to the other side is going to be minus 28, and positive 4 minus 28, we've got minus 24. We're equating everything to 0, and the factors of 24 that will also accommodate minus 5x are minus 8 and 3, minus 8 and 3, minus 8 and positive 3. That's because minus 8 times 3 equals minus 24, and minus 8 plus 3 equals minus 5. So in that case, our value of x equals positive 8 or negative 3. So from here, you know what to do. We are going to plug the x values into the original equation and see which one, or if both of them suit this equation. Give us a real root and equate the left hand side to the right hand side. So we will have the square root of, we start with the 8 plus 28 equals 8 minus 2. 8 plus 28 is 36. Then we have the square root of 36 equals 8 minus 2 equals 6. The square root of 36 is 6. It's equal to 6, and this is correct. But then now let us check. Now I'm choosing you, Mr. Green. Let us check if minus 3 will also give a real root and equate the left hand side to the right hand side. So we'll say the square root of minus 3 plus 28 equals minus 3 minus 2. What's minus 3 plus 28 is 25. Then now we have the square root of 25, which equal to minus 3 minus 2. Let the minus be visible. Square root of 25 equals 5. It's equal to minus 3 minus 2 is minus 5. And minus 5 is not equal to 5. So we say this. 5 is not equal to minus 5. Then our correct value of x is 8 only. That's how easy this can be. So you can pause and double check and do anything like that. And if there's any question, then you can feel free to text or email me. I'll be available to assist you. So now let us go and check the last one and see how the last one is and how we can learn to solve it from this one. We want to solve for x here. Now we going like square root of 2x plus 5. Yeah, is the square root of this is example number 4. Square root of, never mind, my handwriting is never been handsome, eh? It's just like me. Square root of 2x plus 5 minus 3 over the square root of 2x plus 5 equals minus 2. So if things are like this, then they tend to be very scary, because we cannot transpose this, we cannot transpose this. Of course we can, but I mean, if we transpose it, wouldn't assist us with anything. But what can we do? We know that when we multiply this by itself, that is squaring it, it's going to, I'm going to do this step by step so that you guys don't get confused. You see every step of the way. If we multiply it by itself, it's going to give us what is inside the brackets. And if we multiply the second term by the same, it's going to cancel what is at the denominator. And if we multiply it, because what we do on the left hand side must also be done on the right hand side. If we multiply on the right hand side, it's just going to be multiplied by -2. So now let me give you a moment to try and think what exactly we can do. How do we multiply, and how are we going to solve this one? You've got about 45 seconds. I believe that you have now checked it by yourselves and seen how we can deal with this. If you haven't understood this yet, it's not a problem. We are going to deal with it together. So now let us multiply each and every term by the square root of 2x plus 5. So we will say the square root of 2x plus 5, maybe let's just put it in brackets, times, when I multiply, let us multiply in blue color to show that this is multiplying each term, times 2x plus 5, and also put this in bracket, minus 3 over the square root of 2x plus 5. We are going to multiply this. We can also put it in bracket like this, and we multiply it with a blue color. The square root of 2x plus 5 equals, on the other side we have -2. Yes, the -2. And then we are also going to multiply on the right hand side by the square root of 2x plus 5, simply because what you do on the left hand side needs also to be done on the right hand side. So we multiply by the square root of 2x plus 5. So on the first term, I've shown you from the very first example that when you multiply the square root by the square root of the same by the square root of the same, the answer is equal to whatever that is under the very same square root. So in this case, we are going to have our answer as 2x plus 5. That comes from the multiplication of these two. Remember, let me maybe put this a little bit lower so that we don't get confused. We just have not even the square root, because now we are getting rid of that square root. We now have just 2x plus 5 minus, when we are multiplying this by this, then the boys are going to cancel, simply because this is over 1 and we'll have this canceling each other. Simple as that. If you don't understand, feel free to contact me. I'll explain to you in deeper details, but I guess you've already done this in your grade 8, 9 and 10, but never be ashamed to ask. So here we are left with minus 3 equals, on the other side, there's nothing that we can do about this. We're just going to have minus 2 square root of 2x plus 5. So on the left hand side, we already have something which we can group the like terms from. We have 2x. What is 5 minus 3? It's positive 2. 2x plus 2 equals minus 2 square root of 2x plus 5. I told you never to mind my handwriting. You see the square root is going that way. You'll write it in a good way that side. But now on the left hand side, if we can look, first term we have 2, second term we have 2. Isn't that a common factor? It is a common factor. So we take out the common factor of 2. And what are we left with in the brackets? We are left with x plus 1. When you take out the common factor, you need to make sure that when you multiply it back, you get what is on top. So 2 times x equals 2x, and 2 times 1 equals 2. So we are sorted. We have done this correctly. And on the other side, still, there's nothing that we can do about this. Absolutely nothing that we can do about it at the moment. But we need to solve for the x that is inside there. That is under the square root. 2x plus 5. So if we have it like this, on both sides, I still see something which is common. 2 and 2. So if we have 2 and 2, that means we can divide both sides by 2 just to reduce what we have here. So if we divide here by 2, we need to do it also on the right hand side. You can't do it on the left hand side only. It's also in the Bible. If I give you one, if you hit me on the other cheek, I'll give the other one to slap also. So if we have it like this, then these two is going to, let us cancel and show that we are indeed cancelling, not what I've done there. This 2 is going to cancel this one, and this 2 is going to cancel this one. But never make a mistake of forgetting this, because we don't have a negative at the bottom here. Then we are not going to cancel the negative. It will remain. Let me erase this side just to create some space. I want to erase this side just so we can create the space, but I'll leave what is at the bottom so that we can be able to to refer, and I'll also leave the original equation. I'll just draw a line here to show that we are moving to the other side. So once they are cancelled, we're taking these ones, we are now writing on top there. What do we have that is left? We have x plus 1 equals minus the square root of 2x plus 5. So now at this stage, can we transpose? Yes, we can transpose, but what is it going to help us with? Because it's going to the other side to find the square root, and they are not relatives as yet. We need to make them relatives. How so? Let us square both sides, because now we only have one square root, so we can easily remove the square root. So on this side, what do we get when we multiply this twice? We have x squared plus 2x plus 1. X squared plus 2x plus 1 equals. Now I showed you, I think it was on the second example, that this one will be distributed here and also here. So negative times negative gives us a positive. So we're now going to have the positive. And when we square the square root, we get whatever that is under the square root. So now we're going to have 2x plus 5. Now this is very beautiful, and we can solve for x here. We start by transposing this one, going to the other side, and the friend also follows. And while grouping the like terms on the other side, x squared is always lonely, so it doesn't have a friend. So x squared, and then plus 2x minus 2x, it's 0. We don't need to write it. And then plus 1 minus 5. So we're going to have minus 4. How do we solve for x here? How do we solve for x here? So solving for x, I'll show you two ways of how we can solve for x here. We can, because this is, yeah, let us not forget to equate to 0. We can transpose the 4 back to the other side. We'll be left with x squared equals a positive 4. Now, to remove this, we multiply both sides by the square root. Actually, we implement the square root on both sides. I've shown you that if you put a, let me put it in a different color. If you put a square root here and you have squared it, we have exponent 2 there, we're going to be left with x. But what you do on the left hand side must also be done on the right hand side. So here we are going to have x equals the square root of 2. Whenever you're dealing with a square root, you must remember that a square root has two values. It's plus or minus the square root of whatever that is inside the brackets. I made a mistake here and said the square root of 2 is actually the square root of 4. So what is the final answer here? We're going to have x equals these two values, plus minus 2. In other words, we mean x equals positive 2 or x equals minus 2. So from this step, let us try and see if there's a different way we can apply to solve for x. We cannot only solve x in one way. We can have other methods. We have x squared minus 4. This is a difference of two squares. Where do we see the two squares here? We can reduce the 4 to 2 squares. So now that we have our two squares, and not forgetting to equate this to 0, so this would be equal to x plus 2 x minus 2 equals 0. If you multiply these ones, you need to get this one. That is a must. If you don't get that one, then we don't have the values, the correct factors. Then here we're going to have x equals -2 or x equals +2. So you see we got the same as on the other side. So that's what they mean when they say we have a difference of two squares. But we also need to try these factors. If they both are going to give us a real root and what's on the left hand side will be equal to what's on the right hand side, or one of them is going to give us that, or none of them is going to give us that, because it's a possibility. We cannot rule, we don't rule anything out in mathematics unless we have proven. We need to have proven that to be correct or incorrect in order for us to pronounce it whatever we want to pronounce it. So let me just erase this one and then we can start. Which one can we start with? Let us start with +2. On this one, let us let us substitute x by +2. Then we'll have the square root of, again, never mind my handwriting, of 2 times 2 plus 5 minus 3 over the square root of 2 times 2 plus 5. All these on the left hand side must be equal to -2. If it's not equal to -2, then that value of x is wrong, or that factor is wrong. So what is 2 times 2? 2 times 2 is 4. 4 plus 5, we have a square root of 9. Square root of 9. Looks like it's coming along. I don't know if it's going to give us the right one or not. 3 over, we said it's square root of 9 equals -2. Square root of 9 equals 3 minus 3 divided by 3. We say we want it to be equal to 2. And 3 minus 3 divided by 3 equals 1. Here we have 3 minus 1 equals 2. And we want it to be equal to -2. But unfortunately, it's not equal to 2. -2 and 2 are not equal. So we don't want to make that mistake. Never, ever. So now, let us go and see if the other value of x is going to give us a real root and the left hand side will be equal to the right hand side. So we have the square root of 2 into -2 plus 5 minus 3 over the square root of 2 into -2 plus 5. The square root must cover everything. And this must be equal to -2. If it's not equal to -2, then we will have gotten wrong factors of x, or wrong values of x, or right values of x which cannot give us a real root. So what is 2 times -2? That is -4. This one I just want to do it like this so that we can see everything. Square root minus 3 over square root of -4 plus 5 equals -2. What is -4 plus 5? That is the same as 5 minus 4. It's equal to 1, and the square root of 1 is 1. Minus 3 over, we said it's 1, which is just the same as 3. It must be equal to -2. So what is 1 minus 3? 1 minus 3 equal to -2, which is equal to -2. And it's correct. Very correct. So we need to be very careful when working with these kind of equations, that we do not make a mistake and substitute with a wrong value. You find that you substitute with 2 instead of -2. Just a little mistake can cost you a lot of marks. You saw how I made mistakes maybe twice in these examples. So we need to try by all means to avoid those kind of mistakes. So now I want to share with you the number that you can contact Get Smart with Stanford on whenever you need assistance. Let me just erase this. Ah, so nice technology. Can erase this so quickly. Ah, that's great. And I'll just type it on here. And oh, that technology again is doing its own thing. Technology. My number is 064 064 663 0943. That is the number on which you can call Get Smart with Stanford. Alternatively, you can just no space. Alternatively, you can send me an email at getsmartwithstanford.co.za. We are also available on YouTube. You just follow Get Smart with Stanford and subscribe. We're also available on Facebook at Get Smart with Stanford. We are also available on TikTok at Get Smart with Stanford. You see just how accessible we are. So just follow me on all those platforms and feel free to send your questions whenever you have any. That's it for today, and thank you so much. Goodbye.